I am the sponsor, I am the stakeholder, I am the team lead, I am the chief generator of misspellings in the lab documents. So I have been rather engaged personally in this project because it's very important to me. When March hit, I teach among the courses in my routine teaching rotation is a course on advanced digital systems design. This is a class where many of you freshmen, rising sophomore and junior ECE and CS students, it lies in your future. This is the class where you really learn how to build a computer in hardware. And not surprisingly, this is a class where the lab was pretty darned important. And then March hit and life was very different. And we had to make some really shaky compromises to pull off the class last spring. And I knew that would not be good enough going forward. And Amanda and Oliver, my two partners in crime here, were in that class and observed firsthand the challenges of attempting to do a lab class without a lab over Zoom. And they joined with me in this quest to ponder the question, given the summer, what could we do to make this class COVID proof, or at least COVID resistant? And by the way, it's just a good time to refresh this course anyway, because it's been a few years since we've done that. So with that, who needs the power to share?
So, John, I wonder, because it's not 2 p.m. yet, I'm concerned that there might be people, I just would like to give people till 2 o'clock.
Okay.
What do you think, Jen? Because they might be coming from other presentations.
What time is it?
It's 3 minutes to 2.
Yeah, 7.
Yeah, so if people could just hang tight, I would hate for anybody to miss the beginning of the presentation because we started early.
So I also say to sort of give them cover in advance. The stuff they're doing is complicated because you've already had numerous ECE and CS classes by the time you get to this class. And we've worked hard to make the presentations accessible, but nonetheless, this is real stuff. And this team gets the pleasure of presenting to my ECE faculty colleagues in the next couple of weeks to talk about what they've done to an audience that will full well understand what they've been up to and doing this with me. And we should probably, I think we decided to make the presentation more professional. So we cut out the picture of why Amanda can't have a background, but we tried, and her let's say very wise and experienced computer simply is not up to the task of running a Zoom background, and the result is rather scary and terrifying. So yes.
I think it would be safe to go ahead and begin now.
Okay.
Okay, awesome. So again, welcome to our digital systems curriculum redesign presentation. We've been working all summer on this project and hope you enjoy learning about our progress. And we also ask that you save any questions for the Q&A section at the end. So the EC 350, so just before we start, we want to introduce the team. My name is Amanda. I'm an EC major with CS and BMS double minors, and I'm graduating in December 2020.
My name is Oliver Rodas. I am an EC and computer science double major, and I'm part of the class of 2021.
So the EC 350 digital design curriculum, as Dr. Board just mentioned, has served us well for many years, but as many technologies have changed over time, it has been due for a refresh. COVID-19 itself has brought forth remote learning, both making the change more urgent and changing the nature in which we must conduct the course. In its current form, there is no way to deliver the lab and project components of the course to remote or isolated students. So throughout the summer, we've considered every possible scenario: a blended classroom, completely online, and even sending students home in the middle of the semester in case there was an outbreak. However, due to the recent change in junior and senior on-campus housing, we have shifted the curriculum to an online-only classroom setting, since juniors and seniors are the primary students enrolled in the class. So the ECCS 350 course is the core course for the digital systems track in the EC department. And as you may know, many courses in the CS and EC departments teach you how to program a computer, but this course specifically teaches you how the computer hardware is built. So as you can see in the diagram, ECCS 350 is the part 2 to ECCS 250, which is a core course for both majors, where students learn about the design of a computer processor, or CPU, with memory and input-output elements. EC 350 takes this course one step further by building the processor in hardware using a hardware description language as the code. Hardware design is like software in that we do have to write code, but the software programming languages like Java, Python, and C all execute instructions sequentially. However, the hardware description languages, as the name suggests, describe the connections within the electronic circuits and systems, which all execute the wires simultaneously instead of sequentially. And by the end of the course, students build a simple computer processor, using Verilog, a type of hardware description language, and use it to build their final project. So at the beginning of the project, we set forth several goals, keeping in mind that some could be accomplished by the end of Code Plus, and some would need to be addressed throughout the fall semester. Our 3 goals that we accomplished this summer are gathering accessible course tools, establishing a streamlined tool chain, and developing a remote lab environment. Accessible equipment was the first goal that we tackled, considering that students without the right resources could not complete the curriculum from home. We researched and user tested cheaper, but just as effective programmable hardware boards and settled on the Nexus A7-100T board, which is pictured on the left, with an academic price of around $150. We also assembled a list of all the hardware elements and lab assignments and have put together kits to send to remote students. Each student will check out one board and kit from the EC department to complete the entire course from a remote location.
Instead of using the old, slow, and clunky software environment that looks like it was made on Windows XP, we will be using 2 new software environments. The first is Icarus Verilog, which is a simulation platform that allows for rapid prototyping and runs on all platforms. The second is Vivado by Xilinx for programming and integrated testing. We have rewritten the labs to be self-guided and less reliant on the TAs. And we will retain partners using Zoom breakout rooms, which TAs can navigate to answer questions. The changes will remain even after Duke transitions to in-person learning, as we are encouraging students to form a deeper understanding with the designs they create and understand why their modules work. We will now demo one of the newly rewritten labs that serves as the student's introduction to interfacing with the real world. Hi, I will be demonstrating a lab that we have rewritten for this course. It is one of the capstone labs that serves to show students how to interface with a VGA monitor and opens their eyes to the potential of their final project. Here, we have a Nexus A7 development board, a VGA-capable monitor, and a USB keyboard. On the Nexus A7, we will be using the VGA port. You can see that it is the thick blue cable at the top of the board that connects to the side of the monitor. We will also be using the onboard USB ports. The top USB port will be used later in the lab, and the micro USB port will be used for programming. The board is currently turned off. You can see that the monitor is displaying the no signal message, meaning that there is nothing being sent. We will be using a VGA controller circuit that we have pre-built for students to use in this lab. When I turn the board on, you can see that the display is updated to show the board's out-of-the-box demo. It shows all kinds of onboard sensors, including an accelerometer, microphone, and temperature sensor. To begin the lab, students will upload a provided hardware design to the board. I will upload the design now. On the right, you can see the design that we will be putting to the board. This design renders an image from a memory file, similar to how your computer renders your current background image. You can see that the image is now being rendered on the display. The image is created by providing color value to each pixel on the screen. By modifying the memory files, we can control the image that is rendered on the display. The next part of the lab is to do just that. Students will modify the provided memory files to create their own custom image. The image students create will consist of 2 colors. The top of the display will display one color and the bottom the other. I will upload an example of this file now. We chose a light purple for the top and a minty green for the bottom. We can draw on top of our image, similar to how your computer draws on top of your background image to create your desktop. The next portion of the lab has students render a square over their two-toned image. The square must be able to move in the 4 cardinal directions, up, down, left, and right. I will now upload an example of this design. As you can see, we have successfully drawn a red square over the two-toned background image. The left button moves the square to the left, the bottom button moves the square down, the right button moves the square to the right, and the top button moves the square up. We have also accounted for button combinations in moving in diagonal directions. The final portion of the lab has students rendering an image inside of their square. The image must move with the square, and the image to display must be controlled by the keyboard. We will be directly translating key presses into their respective characters. We will provide students with the font to use, and they must modify the design to display it. I will upload an example of this design now. As you can see, we have successfully rendered a lowercase I where the square used to be. We can change the character by pressing a key. Here I have changed it to a J. We can use any letter on the keyboard. Students will only need to render capital letters and not need to worry about the lowercase. We can move the character anywhere on the screen in the same way that we move the square. We can also change which character is displayed as we are moving it. Students also have to account for the number keys and render the corresponding characters as well. We hope you have enjoyed our demo and our presentation. Thank you. So moving forward, we plan to launch a website that contains all of the course info regarding homework, labs, project checkpoints, and lectures. We will also have links to other documents regarding installation and usage of the new software environments, as well as tools like Piazza and Gradescope. Amanda and I will continue as TAs for EC350, and we will help to train the new ones in how to use and install the new programs. We will test the labs on these TAs and gather feedback on how to better guide students. We will also modify the documentation for the final project and its checkpoints to better reflect the online status of the course. We will finally build and ship the kits that we plan to have students use for the labs. Thank you for listening to our presentation. We will now take questions.
We worked really hard to shorten the presentation this morning. We may have worked too hard, so.
That was excellent.
Great job. No, 10 minutes is, that's what we expected. 10 to 15 minutes was what we gave everybody. So that was great.
Good.
So John, how will this impact your class?
Well, it means I can do it. The students actually will get to build hardware from their living rooms and bedrooms all around the world, as opposed to a rather less satisfying simulation of hardware that we had to settle for last spring. Oliver and Amanda have both beaten me up to better organize the way we communicate. We had quite a sprawl of communication and collaboration tools that we were using in the class, and from their work, we will be tightening that up so that there will be, I think, a more coherent flow of information in the course. And as they noted, everything we've done here are things we will keep whenever COVID is behind us. It is now just a better course. The software is easier to use. The hardware is easier to use. The hardware is cheap. This stuff is now textbook priced. Right now, the department's still buying these for everybody, but we can even imagine people wanting to keep their own after the class going forward. The old clunky stuff we used to use is still sold and costs $600 a pop, and the software I like the way Oliver put it, has not benefited from modern user interface evolution.
Very diplomatic.
Yeah.
So John, are there other courses that could benefit from this?
Yeah, well, that's why they're going to have the pleasure of trial by fire in front of my faculty colleagues soon. That we have a couple other classes that build directly on hardware description languages in the curriculum at the 500 level. So they may be immediately interested. Some of our senior design classes, all engineers have to actually take what's called a capstone engineering design class to prove they're grown-up engineers ready to graduate. Several of those do or could use this technology. So yes, there are a handful of other courses that would directly benefit from this.
And is this something that we could potentially share with other universities?
Perhaps. I mean, I don't use Sakai very much because I like my course websites to be open to the world, and similarly, I benefit from rating the good ideas of colleagues at other universities. I think we would want to do a dry run, not a dry run, an active run of the class this fall, and probably again next spring under slightly more normal circumstances before we decide whether this is worth writing up for some of the engineering education publications.
Mm-hmm.
It looks like we have some also group chat messages that have been asked. One of them was, is the single mailed kit used for multiple lab assignments? And so we've actually aggregated all the materials that they would need for each lab assignment and sending it all out at once so that they could have access to all the materials.
We have 7 labs. There are lots of labs. You'll
Yeah.
love them all when you get to this class.
And then
I guess another question is what students learn from this particular project, mainly technologies. I guess the whole course basically teaches you how to specifically program hardware so that it can be used in any different way that you may want it. And so you learn how to use Verilog, which is a hardware description language. And then you also learn how to implement some things in hardware on a breadboard that are usually used in digital design logic.
So what were the most challenging part of this for you guys, for Amanda and Oliver?
So I think a big part of this was writing a lot of the documentation for the new tools we'll be using. I wrote some quick installation programs, and a lot of that was learning Bash. And writing the documentation on how to actually install and use all of the programs and making that easy to read and retracing all of my steps to make sure that I captured every step in the installation process. We mess with virtual machines, and a lot of that was new to me and setting, especially on my local machine using Linux. So I wrote a lot of documentation regarding that and was kind of going into things somewhat blind, and Google was my friend in this case.
Yeah, I would say another aspect that was really challenging was rewriting the labs themselves so that we knew that everything could be done from your home. We had to take out some parts that required an oscilloscope or even a function generator because it's not feasible to send that out to students. So instead we opted for demos, and even just taking the labs that have been altered slightly throughout the years, but not actually looked at all as a whole and changed, just completely redoing them and reconsidering what the tasks are that we ask the students was an interesting challenge that I think extends beyond the hardware and technical component of the class and really focused on how we would be interacting with the students as lab TAs and things like that.
And one of the insights Oliver and Amanda led me to was to realize that even though we will have a synchronous lab component and there will be a TA present, we needed to reconfigure the labs to be much more self-guiding. In the past, we could just, we could be pretty terse and incomplete in the lab because there was always a TA in the room to explain everything and get it right. And we're trying, and this has forced us, me especially, to think very carefully about the language and the level of detail in the lab so that they can be much more standalone with the TAs as a resource rather than as a necessary guidepost.
So all in all, Amanda and Oliver, what did you think of your experience?
I thought it was.
Go ahead, Oliver.
I thought it was great. I learned a lot. I learned a lot of how to explain myself, especially when rewriting the labs, to make sure that I was explaining everything as much as I could correctly. It really helped me learn to present and really emphasize certain things, especially like in a presentation like this. And in a lot of the documentation that we wrote, I think writing documentation and explaining to people how to use or how to follow the steps that you've created is a very important step, especially in engineering. And I feel that I got a lot of experience in that.
Awesome.
I think like one of the really cool things that I learned was just like how to learn and teach in an environment like this, which is kind of the direction that our world is heading in, even without COVID. Like I did an internship at a remote company last summer, and so seeing like how that translated to this kind of work was really interesting, and just like thinking about like those relationships that wouldn't necessarily be cultivated in an in-person setting, and how can we transition to like move forward in that sense. And so I eventually like want to get into like product design and user experience design, so like applying that mindset to this project was really beneficial, and like I really learned a lot about how I can consider certain things. Yeah.
Good. Excellent. Any other questions or?
There's just a comment. That's something I never really thought about. Writing documentation may be harder than actually making the device or the program. Ah.
Yeah, I agree with you.
Yeah, it's challenging.
Yep.
That is the way to become a beloved engineer at your company, is to actually carefully describe what you did for the person who gets the joy of coming along behind you and doing phase 2 of your project.
I'm a huge advocate of good documentation. It's a thing for me.
Yeah.
It's almost your job title, so it's
That's wonderful. Any more questions? We're done just on time.
Hey, John, one question. So I see this is one of the, I guess, like a rare project this year where you are the chief stakeholder and chief project lead and everything for this project.
I paid, damn it.
Yeah.
Yeah, exactly. And yeah, so I guess how did it at all change from what you envisioned during the process with students, or it came out exactly what you were looking for?
Well, I mean, I went in knowing it was an exploration of how to do the class better. So I did not have, the only set idea I had coming in is I need to make my class better.
Right.
Because what I had just come out of was not good enough. And so I think all three of us came in pretty open-minded as to where we would end up. But fortunately, my suspicion that there was more modern hardware and software out there was true. And the first couple of weeks were Amanda and Oliver. We ordered what, a dozen different boards and tried 4 or 5 different pieces of software. And very, very quickly persuaded me that yes, there was much better hardware and software available, irregardless of COVID, that would just make the class better and more modern. And then everything else kind of rolled from there once we selected a particular platform to focus on.
Wow.
Win-win all around.
Can't wait to hear the feedback from the other, from your peers, John.
They're a fair group.
Oliver and I are a little nervous to present to them, but it's okay.
You'll do great.